All right, welcome back. So today I'm going over if statements. Now, these are all of our comparison operators to use in an if statement. So pretty much what an if statement does is make decisions based on number representations and variables. So you could do things like this. So if A is more than 1, which it's not, then you could print, let's say A is more than 1. And then we can make another decision where else if or elif A is less than 1, then we can say A is less than 1. But there's three things that could happen. A can be more than 1, less than 1, or equal to it. So instead of saying elif A is equal to 1, we can say else, because it is the last decision that can possibly happen. So we can say else A is 1, and that would work. So if we run this program, we'll get A is 1, because that is the one that is true. A, which is 1, is not more than 1, it's not less than 1, so it has to be 1. So another way that we can evaluate something using an if statement is, let's say print A. Say print A if A is more than B. Else print B. So we know that B is more than A. So we're not going to print A if A is more than B, because A is not more than B. So we'll go with the second option and print B. So this is what we should expect. B. Correct. So another thing we can do is evaluate more than one thing at a time. So let's say if C is more than A or B is more than C, then we can say one of these statements, actually arguments, are true. So will it print that? Yes, it will, because C is more than A. So only one of these have to be true. Both could be true, but if none are true, then nothing will print. So let's say that A is more than C. Then nothing ran. Nothing was printed out. So let's say both conditions have to be true. So let's say C is more than A, and we go, let's print, both conditions are true. Is it going to print this? No, it's blank. Here, just for better representation, it's blank, because while C is more than A, B and C are equal. So if you want to include these, then it's more than equal to. And now it should print. So another thing you can do, similar to one of the past demonstrations, was if A is equal to 1, then you can print A is equal to 1. Now, why can we do this? Because, well, if we do A equals 1, that's assigning A is equal to 1. But this weighs the options of, is A equal to 1 or not? And if you said, well, here, let's demonstrate it first. Now, if we said A is not equal to 1, then we'll print A is not equal to 1. And it won't print because A is equal to 1. So let's say 2. Let's say 2. A is not equal to 2. Exactly. So now, one thing we can do is, instead of using integers or floats, because this works with floats as well, actually works with a lot of things, so we can also use strings. So let's say s1 equals a string, and s2 is the same thing. Now we can do, if s1 is equal to s2, then we can print these strings are equal. Will it run? Yes, it will. Now let's say I lower fixed it. Now what will happen? Nothing will be put out. So let's clear that and let's make a proper fall through structure. Else print these strings are not equal. And it will print these strings are not equal, just like that. Now, if else, this is an if else structure, but like we had it in the first example, just like this, that is a proper fall through structure where you have an if, an elif, and an else where all conditions can be met. Now, you can have multiple elifs, but you can't have multiple elses. So let's say a is equal to 1. Just like that. We'll just have a is equal to 1. Now it'll run a is equal to 1 because it goes through this condition, which is not true, so it goes through the next condition, which also isn't true, so it goes through else. And that's the meaning of a fall through structure. All right. Thank you for watching, and hopefully you learned something from this.